At the close of their analysis of Linde's chaotic inflationary model, Bord and Vilenkin say, with respect to Linde's metaphysical question, the most promising way to deal with this problem is probably to treat the universe quantum mechanically and describe it by a wave function rather than by a classical space-time. They thereby allude to the next class of models which we'll discuss, namely quantum gravity models. Vilenkin, and more famously James Hartle and Stephen Hawking, have proposed models of the universe which Vilenkin candidly calls exercises in metaphysical cosmology. In his best-selling popularization of his theory, Hawking even reveals an explicitly theological orientation. He concedes that on the Standard Model, one could legitimately identify the Big Bang singularity as the instant at which God created the universe. Indeed, he thinks that a number of attempts to avoid the Big Bang were probably motivated by the feeling that a beginning of time smacks of divine intervention. He sees his own model as preferable to the Standard Model because there would be no edge of space-time at which one would have to appeal to God or some new law. As we shall see, he is not at all reluctant to draw theological conclusions on the basis of his model. Both the Hartle-Hawking and the Vilenkin models eliminate the initial singularity by transforming the conical hypersurface of classical spacetime into a smooth, curved hypersurface having no edge. This is accomplished by the introduction of imaginary numbers, that is to say multiples of the square root of -1 for the time variable in Einstein's gravitational equations, which effectively eliminates the singularity. Hawking sees profound theological implications in the model. I quote, "The idea that space and time may form a closed surface without boundary has profound implications for the role of God in the affairs of the universe. So long as the universe had a beginning, we could suppose it had a creator. But if the universe is really completely self-contained, having no boundary or edge, it would have neither beginning nor end. What place, then, for a creator?" Hawking does not deny the existence of God, but he does think that his model eliminates the need for a creator of the universe. Now, the key to assessing this theological claim is the physical interpretation of quantum gravity models. By positing a finite imaginary time on a closed geometrical surface prior to the Planck time, rather than an infinite time on an open geometrical surface, these models actually seem to support, rather than undercut, the idea that time had a beginning. Such theories, if successful, enable us to model the beginning of the universe without an initial singularity, involving infinite density, temperature, pressure, and so on. As Barrow points out, this type of quantum universe has not always existed. It comes into being, just as the classical cosmologies could. But it does not start at a Big Bang where physical quantities are infinite. Barrow points out that such models are often described as giving a picture of creation out of nothing. The only caveat being that in this case there is no definite point of creation. Hartle-Hawking themselves construe their model as giving, quote, "the amplitude for the universe to appear from nothing," end quote. And Hawking has asserted that according to the model, the universe, quote, "would be quite literally created out of nothing, not just out of the vacuum, but out of absolutely nothing at all, because there is nothing outside the universe," end quote. Similarly, Vilenkin claims that his model describes the creation of the universe, quote, "from literally nothing," end quote. Taken at face value, these statements entail the beginning of the universe. Hence, Hawking evidently means to include himself when he asserts, today virtually everybody believes that the universe and time itself had a beginning at the Big Bang. Hawking's theological statement, quoted a moment ago, on the theological implications of his model, must therefore be understood to mean that on such models, there are no beginning and ending points. But having a beginning does not entail having a beginning point. Even in the Standard Model, theorists sometimes cut out the initial singular point without thinking that, therefore, the space-time no longer begins to exist. And the problem of the origin of the universe would be thereby neatly solved. Time begins to exist just in case for any finite temporal interval there are only a finite number of equal temporal intervals earlier than it. That condition is fulfilled for quantum gravity models as well as for the Standard Model. Thus, quantum gravity models, like the Standard Model, imply the beginning of the universe. Perhaps it will be said that such an interpretation of quantum gravity models fails to take seriously the idea of imaginary time. Introducing imaginary numbers for the time variable in Einstein's equation has the peculiar effect of making the time dimension indistinguishable from space. But in that case, the imaginary time regime prior to the Planck time is not truly a space-time at all, but rather a Euclidean four-dimensional space. Construed realistically, such a four-space would be evacuated of all temporal becoming and would simply exist timelessly. Thus, Vilenkin characterizes this regime as a state in which all our basic notions of space, time, energy, entropy, etc. lose their meaning. Hawking describes it as completely self-contained and not affected by anything outside itself. It would be neither created nor destroyed. It would just be. The question which arises for this construal of the model is whether such an interpretation is meant to be taken realistically or merely instrumentally. On this score, there can be little doubt that the use of imaginary quantities for time is a mere mathematical device without ontological significance. For first of all, there is no intelligible physical interpretation of imaginary time on offer. What, for example, would it mean to speak of the lapse of an imaginary second, or of a physical object enduring through 2 imaginary minutes? Secondly, time is metaphysically distinct from space. Its moments are ordered by an earlier than relation, which does not similarly order points in space. But this essential difference between time and space is obscured by imaginary time. Therefore, imaginary time is most plausibly construed as simply a mathematical auxiliary device to grease the equations and get to realistic answers. Significantly, the use of imaginary quantities for time is an inherent feature of all quantum gravity models. This precludes their being construed realistically as accounts of the origins of space-time in a timelessly existing space. Rather, they are simply ways of modeling the real beginning of the universe ex nihilo in such a way as to not involve a singularity. What brought the universe into being remains unexplained on such accounts. So whether its origin was at a singular point or not, the fact remains that the universe began to exist, and this is a prediction of any realistic interpretation of quantum gravity models.